Hey guys, welcome to LZH project. My name is Salman Francis and this is ninth part of Linux basic networking series. And in today's video, we are going to take a look at Traceroute. This is a must-have utility for all the network engineers and all the people who are dealing with networks and Linux operating system. So basically, what is Traceroute? It basically tracks the packets, displays the path of the packet, and is used to troubleshoot networking issues. It uses IP protocol's TTL field, and TTL stands for time to live, basically. TTL prevents a data packet from circulating indefinitely over the internet, and with TTL, we can also differentiate between various platforms, such as TTL of 64 is for Linux. For example, I'm using Linux machine, and if I ping localhost, you will see a TTL value of 64. Similarly, my router or my gateway is the Linux machine, and you can see it's a 64. I don't have any window box, but if you ping window box, it will give you a TTL of 127 or 128, and same for Cisco routers or other routers, it will give you TTL of 255 or 253, something like that. And so that's how you can also differentiate between the platforms based on TTL. So, okay, so what can we do right now? Actually, let me show you or explain you the purpose of TTL. Okay, this time to live value. So each time the packet finds a router, okay, so let's say this is a packet, and let me clear the screen. I tried to draw that on my computer, but I cannot find my drawing tablet, so that's why you have to bear with me. Okay, so let's say this is a packet, okay? And this packet, whenever it goes over the network and whenever it finds a router, let's say this is a router, okay? So each time the packet finds a router, the TTL value is decremented by 1. It means minus 1. Okay, the TTL value is decremented by 1. This is very important to understand. So if the TTL value reaches 0, so what happened? The packet is destroyed. So this keeps a lost packet from traveling around the internet forever. For example, let's say this packet value or this packet has a TTL value of 1. It starts with 1. Okay, so whenever this packet finds this router and whenever the router is found, the TTL value is subtracted or decremented by 1. This means 1 minus 1, okay, equals 0. Okay, so when the TTL value is 0, the time exceeded message is sent to the source machine. Okay, what is sent? Time exceeded message is sent to the source machine. For example, this is the source machine. Okay, so this source machine sent this packet of TTL value of 1. When this packet founds the router, the value is decremented by 1. And when the packet reaches or the TTL value reaches 0, the time exceed message is sent to source machine. Okay, and what happens actually, this source machine also receives the information about this first router. Okay, now what happens then? This next time the source machine sends the TTL value of 2. Okay, and then when it finds the router, this time the packet is subtracted, like decremented by 1. 2 minus 1 is 1. Okay, so what happens now? The packets travel further, and whenever it finds the router, let's say R2, this time the value is 1 minus 1 equals 0 again, and then the time exceed message is sent to back to source machine. So this time the information of second router is received. Okay, now our machine will send the TTL value of 3. First router will decrement packet by 1. The value will be 2. Second router will decrement, the value will be 1 this time. Okay, then the packet will travel further, finds the third router, okay, and the value will be 1 this time, decremented by 1, and the result will be 0. And this time exceed will be sent to source machine, which will also receive all the information of this first router, second router, and third router along with their IP addresses. Okay, so that's and this continues like until this this basically process continues, okay, and until the final destination is reached. And so how Traceroute knows when to stop actually? Like otherwise it will just keep on sending TTL's value, but how actually it knows that the final destination is reached? Actually what happens, this time exceed message will not be sent when the final destination is reached, but ICMP port or destination unreachable message will be sent. We will just take a look at the demo and you will understand, but I just want you to make it clear that when the final destination is reached, the time exceeded messages, the source machine will not receive this time exceed message, but it will receive ICMP port or destination unreachable message, okay? And when this happens, the Traceroute will stop sending the packets. So let's see this, and by default Traceroute will use UDP packets, okay? And in this video we will see TCP Traceroute also, and how to send ICMP packets. So let's open our Wireshark. Okay. Okay, so here's Wireshark, and what I'm going to do is I am going to select this and stop it. So this is the source. Okay, let's try to see if it works. Traceroute. Oh. Okay, so it started, and let me just, it's done, stop, and let's see this. So what happened actually, you can see that it's a UDP protocol. That's why Traceroute use UDP by default. Okay, and you can see here, as I was explaining you, that time to live exceeded message is sent when this is the first router. Okay, my gateway, and ICMP time to live exceeded messages sent. Then we go further. Okay, time to live exceeded messages sent again, second router, and further again this time to live exceeded messages sent. So this means this Traceroute is continuing, and when it will reach the destination, it should give us destination or port unreachable. Here it is. So that's perfect. Like we know that this is the destination which we tracerouted, and when it how it came to know that destination unreachable port message was received. Okay, clear? Okay, apply. Okay, so now I'm going to go back to this terminal. Clear? Okay, so this demo clearly showed you how the traceroute with works by default. Okay, so now we will see demo of how we can use this traceroute with TCP or a TCP traceroute. So TCP traceroute works the same way, only the option is traceroute -t. Okay, with the same thing, but how it will work actually? It will work the same way, but the messages are different. Let me show you. Okay, here, say, okay, no need to save. Okay, okay, it started. This is the TCP traceroute. Okay, we are waiting. Okay, done. So back to our trace file. Okay, you can see here the protocol was TCP. In last time when we sent traceroute, when we used or started traceroute by default, it was using UDP packet. But with -t option, it used TCP packets. Okay. Sometime, why do we need TCP traceroute? Because sometimes UDP packets are closed and TCP is open, so we can use TCP to check the path that it's working or not. Okay, so coming down. Okay, sorry about that. Here. Okay, so you can see that it started with the time to live exceeded, same as with the UDP, but how it comes to note that the final destination is reached when it sends the reset packet actually, or the SYN packet. Well, basically what happens actually, it sends a reset packet package or packet, sorry, or it sends a SYN packet. So time to live, time to live, time to live, and here you go. So it sent a SYN packet, and that's how it understands that the final destination is reached. We can check the same. Let's stop the packet, and no need to save. I don't know why I'm saving. So okay, let's start. Instead of this, let's do another DNS, Google DNS. Okay, try this time. Let's see if it shows the SYN packet or the reset. Okay, let's see. Stop. Okay, so it started with the TCP, perfect, then time to live exceeded, and going and going and going, and again with the SYN. So whenever it received the SYN packet, it understands that the final destination has been reached. It has to do with the HTTP also. port. If HTTP port is open, it sends. Let me show you one thing. Okay, so let's trace route with Yahoo 46.228.47.114. Okay. Continue without saving. I just wanted to show you that sometimes you receive the reset actually. Okay, it's done. Stop. Again TCP. Going, time to receive. Yeah, here you see. So it gave you the reset. When port 80 is open, it gives you reset, and when it's not open, it gives you the SYN. So that's how the TCP traceroute understands that the final destination is reached. Okay. Now last is ICMP. Okay. Close without saving. And how we can send ICMP? We can send ICMP by -I option. Okay, it works the same way, but this time I haven't pressed enter. Let me stop this. Okay. Okay, it will work the same way, but with -I option, but the end message is different. Like how it's going to understand that the final destination is reached, it will receive an echo reply. Okay, pressing enter. Okay, done. Let's check that. Okay, and it started from here. Here. So echo ping. So this is the ICMP. It started this trace route from my computer. You can see my IP address to Yahoo ICMP. Okay, perfect. This is TTL1. You can see time to live 1. Basically, why there are 3 TTLs, because it takes the average. So that's why you can see that TTL1 3 times takes the average. Okay, and then you can see it receives time to live. But how it's going to understand that the final destination is reached, it will receive an echo reply actually. Okay. I think it's not complete. Echo reply. Okay, let's start again. This time we'll try to hurry. Okay, it started here, and time to live. Okay, let's wait. Okay, still not showing. Okay, let's try to . send this to some other. Okay. ICMP started. And here it is, echo reply. So that's how it came to know that final destination is reached. Perfect. So I'm just going to turn off this. Okay, so I hope you guys have now a better understanding how Traceroute works and how it's helpful in knowing the exact uh, how it works basically on the wire, on the network, and behind the scenes actually how it works. And I hope you guys have better understanding, and now you can uh, check it properly with Wireshark or TCP dump, that how you can this traceroute tool works, and now you can trace the path with professionalism. All right, thank you for watching, and please do subscribe to my YouTube channel. Like us on Facebook. It's Linux King 77 on Facebook and Linux King on YouTube. Thank you and God bless.